I hope you're all doing okay, Mr. A, and I hope everybody's adapting and putting up with the unpleasantry of this coronavirus. This is my first attempt at online. We're going to go through a brief lecture and getting into the next steps. I'll explain more as I go. First, let's talk about, you've probably seen this at least 452,000 times, coronavirus safety. Disinfect surfaces, wash your hands, and hopefully we're staying away from others right now until they figure out more steps moving forward. What are we going to talk about today? Your next project is going to be around P&IDs, their process and instrumentation diagrams. I'll tell you what the deliverable is going to be, what we're planning on doing the next couple weeks as I adjust this course. And on top of that, read Chapter 4 in your piping book. I'd ask for this time for questions, but a lot of you don't ask questions. So, P&ID, it's a piping and instrumentation diagram drawing. It's defined by the Institute of Instrumentation and Controls as a diagram which shows the interconnection of process equipment and the instrumentation used to control the process. In the process industry, a standard set of symbols is used to prepare drawings and processes. Again, this is a standardized type thing. Each company might have different symbols to project different pieces of equipment. But depending on where you go in the world, it's pretty tight. Anybody can read another country's process and instrumentation diagram. For example, this could be considered as a quick process instrumentation diagram. In this case, you have a pump skid. It tells you what size it is. There's a gate valve, a reducer, flow element, another check valve, a globe valve in this case going over to a condenser skid. In P&IDs, there's no scale. You don't know from the pump skid to this flow element whether it's 5 feet or 505 feet. So what's on the P&ID? Again, there's no scale. You have to space things accordingly in order to lay it out on your drawing. This is an example of a tank. It gives flow. You see the flow arrows. It shows valves. It shows instrumentation, hence the name process and instrumentation diagram. This might be a pressure transmitter. Dotted lines show electric. This might control this valve to either open or close or throttle depending on the pressure, for example. Again, for your case, drawing your first process and instrumentation diagram, space it out accordingly. Use drafting skills in order to lay it out so it looks pleasant to the eye. Space things accordingly. So, things are organized. It's logical. As you read a drawing, like I've said, left to right, everything's identified. It's easy to read. It's used for design. It's used to maintain. What do I mean by that? It's used for design for the process engineers to, for example, look at this diagram, and they can understand without looking at the piping diagram's details. They'll show how this entire plant operates. If you go into a process control room, they'll have this diagram up on the wall or electronically, and this is exactly how they will control the plant, how they operate the plant. So for your particular case, what you need to do is lay out the drawing. Nothing's to scale, but it's got to be identified and easy to read. So what's usually on the P&ID? Instrumentation, unique tag identifiers, mechanical equipment, all valves, process piping, the size, flow direction, interconnections, interfaces, computer control systems, identification of components and subsystems, etc. So here's another example. If not knowing where this is or what it does, what it's manufacturing, as a designer, you should be able to read the flow, read the sizes. For example, this pipe here, if you can see my mouse, is a designation of S2. This has an identifier specific for this company that it looks like it's a 4-inch pipe, but this might mean that the type of material, where it's going to and from. I wish I could ask if you have questions. I'm sure you do, but let's try to get through this together. But there's an example of. P&IDs, they also play a role in the maintenance. For example, if you go back to this drawing as an example, and they might have a change in the field 2 years after you've designed this, that this might go from a 4-inch to a 6-inch. What they'll do is update the P&ID. They won't necessarily change the piping drawings. So once you get out there in the real world, what you'll end up doing is changing the P&ID because it's simple and they need to maintain what's going on out in the field at that particular plant. So this is their record that shows what's changed and what's new. The bottom line is the P&ID, as a piping designer or drafter, the P&ID is your Bible. This is the particular point from where you start. If you have this drawing again and you're starting as a piping designer, this should tell you a bunch of information, line sizes, where you're going to and from, what the equipment is. It will not tell you how to lay it out, where the pieces go, but it will tell you the size of the pipe and where you're routing it to and from. Again, piping, the P&ID process and instrumentation diagram is going to be considered the Bible for you as a piping designer. Now there's a bunch of instrumentation symbols on each P&ID. Here's an example of the different types. You don't need to necessarily know what they do. I'm going to give you an exercise to do at home. But for example, as you're looking through these, TI would be a temperature indicator. A PIC might be a pressure indicator controller, and these might be examples of what they look like. These are the symbols of what valves would look like on a P&ID, and these down here are what they are. We're only going to use butterfly, gates, and globes in these particular exercises. So what's the difference between a process flow diagram and a piping instrumentation diagram? Process flow is blocks showing the equipment with lines with arrows showing where the pipe is going to and from. P&ID is basically including the instrumentation and all the tags related. Again, this is not to scale. It might vary from company to company to where you might work. This cannot be used to construct. What do I mean by that? This is only a diagram. It shows, again, pipe sizes, where certain instrumentation goes. It does not show how it's hooked up, doesn't show relative size, doesn't show relative scale. So it cannot be used to construct whatever you're designing. Common universal standard, it should include, again, piping, instrumentation, and documentation criteria that will relate to the piping designer and contractor what's going on within the system. I'll also post these slides on Blackboard so you can look at them a little closer instead of me trying to go line by line. So this is your next drawing. I posted this prior to our break. You're basically going to copy this. It's in the Rip Weaver book. It's in Blackboard within the postings of the first few days of the class. I need you to basically copy this drawing as your instrumentation. So the P&IDs due, we're going to go week by week to see how we're doing here. And also, during this exercise, I want you to do the following. For example, here's a pressure gauge. This is what it looks like from a process and instrumentation diagram. This is what it really looks like in real life. So what I need you to do is find 6 examples of, let me go back here and find this, 6 examples from this page here. And what you do is, if it's a pressure recorder, for example, what I want you to do is put the symbol down and find a real-life example on Google. Google it. Copy and paste the picture, and I need 6 of these. All right? So to recap, I want this drawing done. Copy it. It should look pretty much exactly like what you're seeing here. While you're a drafter, you also have to sometimes take old sketches, old drawings, and redo them. So what you're doing is copying this. Everything is readable, and you should be able to copy it with no problems. Another one is 6 examples. Here's an example. Don't use this one as one of your 6 examples. Here's an example of what I want 6 different types of these. Whether it's a flow element, flow alarm, pick 6 out of here and make copies of those. So, moving forward, AutoCAD drawings, send them to me as a PDF. I don't have AutoCAD at home. For the case of the instrumentation example, you can either do it in Word or Excel, but I want those done. If you want 2 on a page, if you can fit 3 on a page, that's fine. So we'll decide when these are due. This is what you need to do next. I will post basically when the next lecture is. These 2 things should be able to be done in a week. The next lecture will be the following week, and I'll have more of a schedule, but this is enough to get you going. If you have any questions at all, email me. I'm not going to look at my email every hour, but I'm not going to hold you to a final day on here as we migrate through this new normal as we're living through this pandemic. I hope you're safe. We'll be in touch, and take care of you and your family.